Hello everyone, welcome to SCI-EASE. In this video, I am going to explain a very important topic of class 11th, chapter 1, Basic Concepts of Chemistry. And the topic is Empirical and Molecular Formulae. Usually, there is question in the board exam and the competitive exam on the basis of this topic. So be particular, be careful, and be ready to solve the numericals based on this topic. Chemical substances, they are named by some specific names. While describing chemistry, we come across these chemical substances or the chemical names of the compounds quite often. So to write the name of the chemical compound and also to write full name of the chemical compound, it's quite difficult and inconvenient also. And moreover, that does not provide any information about the composition of the compound. So, for that, the chemical formulae that is given to each and every chemical compound. So, that will save time also, and it will tell us the number of atoms of each element present in that particular compound. So, in case of covalent compounds, they are the discrete molecules where they are described by the molecular formulae. But in case of the ionic compounds, in case of ionic compounds and covalent compounds which are linked together, that is forming a network like in the case of diamond, and in case of ionic compound like NaCl, they are not discrete molecules. So they can't be described by molecular formula. They are described by stoichiometric formula. And this stoichiometric formula, that is also known as empirical formula. So the two terms, they are clear that how we describe the molecular formula and where we describe the empirical formula. Now these chemical formulae, they are of three types. One is the molecular formula, second is the empirical formula, and third is the structure formula. Here, in this video, I will take up the first two, that is the molecular formula and the empirical formula. Now, what do you mean by this molecular formula? We just write the name of the compound in terms of symbols or formulae. Okay? If the compound is like diatomic molecule, like hydrogen, then we will write it like H2. Okay? So it will save time and it will also tell us that there are two atoms of hydrogen in this molecule. So this chemical symbol H2, it tells us that there is one molecule of H2. In case of water, you can take the example of water. Here it will tell us that here two atoms of hydrogen and one atom of oxygen is there in one molecule of water. If we write water, W-A-T-E-R, it will not give us any information. So what this molecular formula is, the proper definition, a shorthand notation. A shorthand notation for the molecule of substance in terms of symbols and actual number of the atoms. Actual number of atoms of each element present in one molecule of that substance. So this is the molecular formula. I think this is clear to all of you. You have read about what molecule is, what atom is. Now come to the terms molecular formula and empirical formula. Now, I have told you that the ionic compounds or the network covalent compounds like diamond, they are described by the empirical formula. So what is empirical formula? I will take the example also. The simplest formula of the substance, which gives the relative number of atoms of each element present in the molecule of that substance. The thing will become more clear to you by taking very simple example. You must have heard about benzene. It has a formula C6H6. So when we talk about the molecular formula, we will tell that benzene has 6 atoms of carbon and 6 atoms of hydrogen in it. But when we take the ratio of these two elements, that is 6:6. So simplest whole number ratio, that will come out to be 1:1. So empirical formula for benzene, that is only the CH. It is CH. Okay? So this is it will tell us that the two elements which are present in benzene, they are there and they are in the ratio of 1:1. Okay? If the ratio of some compound, that is 1:2:1, suppose, then we can write CH2O. If the element C is 1 and then 2. So the empirical formula, that will come out to be like this. So these elements, they are in the ratio of 1:2:1. Now come to, we calculate the molecular mass of the molecular formula. Okay? When we calculate the molecular mass, it will come out to be 2. 1 plus 1, 2 point something. Okay? And in this case, it will be 2 plus 16, that is equal to 18. So, what is the mass of the empirical formula? How we can calculate it? That is known as the formula mass. Okay, that is known as a formula mass. For benzene, it will come out to be 12 plus 1, that is 13. It will come out to be 13. Because we will come across this formula mass or empirical formula mass while solving the numericals. That is why I am telling you these two terms, that what is molar mass? Molar mass, that we calculate from the molecular formulae, that you know how to calculate. If we are to calculate the molar mass of this water, then it will be molar mass of hydrogen is 2 and oxygen 16, it will come out to be 18 U. Okay? But when we are considering this empirical formula, then its mass, that is known as formula mass or empirical formula mass, and how it can be calculated, that I have told you. In this molecule, it will be 12 plus 2 plus oxygen 16. Okay, add them. So you will come across these two terms. Now, what is the relationship? Now, I am going to tell you the relationship between the empirical and the molecular formula. Molecular formula, that is equal to N into empirical formula. Or how we can calculate this N? N will be equal to molecular mass. How we can calculate this N? Molecular mass over empirical formula mass. Here N may be 1, it may be 2, 3 and so on. These things, they will become more clear when we will solve the numericals. Then there we will calculate N also. Now the first numerical which we are going to solve is determine the empirical formula of an oxide of iron which has 69.9% of iron and 30.1% of dioxygen by mass. So first thing, you are to draw the table like this. Okay, the numerical that will be solved very easily by forming this table. Okay, then second thing is you are to identify the elements present. Here the elements present are iron and oxygen. So the elements we will identify iron and oxygen, they are present. Next column is percentage composition. Percentage of iron is 69.9% and that of dioxygen is 30.1%. This numerical is taken from your textbook. It is in the exercise. So what are the atomic masses of iron and oxygen? Sometimes atomic masses are given. That is, iron, it has atomic mass 55.8% and oxygen, that is 16. Now next step is divide the percentage composition 69.9 by its atomic mass 55.8. In the same way, you will divide 30.1% by 16. Okay? So what will be the answer? It is 1.25 and this is 1.88. Now next step is to identify which one is lowest among all these. Sometimes the elements are 3 or 4. So the lowest is 1.25, that is of iron. So divide this 1.25 with 1.25. Again, you will divide by 1.25. This will come out to be 1. And then divide 1.88 by 1.25. This will come out to be 1.5. As you know that we can't use this fractions in forming the formula. So simplest whole number ratio, we have to multiply this atomic ratio by some numbers so that we can get simplest whole number ratio. So here we will multiply it by 2. So this will come out to be 2 and this will 3. So we have to calculate here only the empirical formula. So iron and oxygen, they are in the ratio of 2:3. So, empirical formula of the compound, that will be Fe2O3. Okay. So this is the empirical formula. So this is a very easy method. Now we will do one more numerical in which both empirical formula and the molecular formula that is to be calculated. Now the second numerical, that is, a substance on analysis gave the following percentage composition. Sodium 43.4%, carbon 11.3%, oxygen 45.3%. Determine its empirical and molecular formulae. So here we are to calculate both empirical and molecular formulae. And the relative molecular mass of the compound that is given, that is 106 U. First, we are to identify the elements present. First element present, that is sodium. Next one, carbon. And third one, that is oxygen. Okay. Now, what is the percentage composition of these elements? Sodium is 43.4%. Carbon, that is 11.3%. And oxygen, that is 45.3%. Next step is the atomic masses. Atomic masses, they are not given here. You should know the atomic mass of sodium. So the atomic mass of sodium, that is 23. You should memorize the atomic masses up to the element calcium, that is atomic number 20. That you should memorize. Now carbon, next is carbon. Its atomic number is 6, atomic mass is 12. Okay. Oxygen, it is 16. So here there are 3 elements present. Now what is the atomic ratio? How you will calculate? Divide 43.4 by 23. So it will be 1.89. Now divide, next is 11.3 by 12. So it is less than 1. Answer, that is 0.94. Next, divide 45.3 by 16. So what is the answer? It is 2.83. What is the next step? We are to identify the lowest among these 3. So this is the lowest one. So divide all these atomic ratios by the lowest number. So 1.89 divided by 0.94. In the same way, 0.94 divided by 0.94. And third one, 2.83 divided by again 0.94. So what is the result? What is the simplest atomic ratio? Here it is 2, here it's 1, and here 3. So the simplest whole number ratio is 2, 1, and 3. So the sodium, carbon, and oxygen. Sodium, carbon, and oxygen, they are in the ratio of 2:1:3. From this, we will calculate the empirical formula. So, empirical formula that is Na2, okay, C1, no need to write 1, O3. So this is the empirical formula of this compound, sodium carbonate. Now what is the next step? We have to calculate the empirical formula mass. How we will calculate this empirical formula mass? Sodium 2 multiplied by 23 plus carbon 12 plus 3 multiplied by 16, it will come out to be, you calculate it, it will be 106 U. Okay. Now the next step is calculate the value of N. So N is equal to molar mass. Molar mass that is given 106. So 106 divided by 106. Okay, what is 106? It is molar mass divided by empirical formula mass. Molar mass divided by empirical formula mass. This is the formula for calculating N. So this is equal to 1. So here N that is equal to 1. This. Now the next thing is how we can calculate the molecular formula. So molecular formula that is equal to N into empirical formula, and empirical formula is Na2CO3. What is the value of N? 1 into Na2CO3. So the answer is again Na2CO3. So here the molecular formula as well as the empirical formula, that is one and the same. Okay, both are Na2CO3. Now, the next numerical I will again do that in which N is not equal to 1. It may be 2, 3. So, the next numerical we will calculate like this. Now, the third numerical, that is the statement of the numerical is, a compound was found to have 38.2% boron and 21.8% of hydrogen. Its molar mass is 27.6 gram mole inverse. What is the molecular formula of the compound? So, we have to calculate here empirical formula, and from that we will calculate the molecular formula. Here the masses, atomic masses of boron and hydrogen that is given. Now first we have to identify the names of the elements present. So the element boron and hydrogen, they are present here. Okay. Percentage composition of these elements, that is 78.2% boron and 21.8% hydrogen. What are the atomic masses? It's given 11, otherwise you should know, and 1. Now we have to calculate the atomic ratio. What we will do? We will divide 78.2 by 11. So what will be the result? 7.1. Here it is 21.8 divided by 1, it is 21.8. Now what is the simplest atomic ratio of this? First we have to identify which one is lower one. So this is the lower one, 7.1. So we will divide 7.1 by 7.1. So it will be 1. Simplest atomic ratio of boron is 1. Then 21.8 divided by 7.1, it's approximately 3. So the simplest whole number ratio, that is 1 and 3. From this we will calculate the empirical formula. So boron and hydrogen, they are in the ratio of 1:3. So what is the empirical formula of the compound? That is BH3. Now next step is to calculate the empirical formula mass of the compound. Empirical formula mass, that will be calculated. How? Boron 11, 3 multiplied by 1, it will come out to be 14U. Now what is the next step? Next step is to calculate N. N, that is equal to molar mass over empirical formula mass. What is the molar mass? It's given 27.6. So 27.6 divided by 14, it will come out to be approximately 2. So the next thing is we have to calculate we have to deduce, you can say, the molecular formula. So molecular formula, that is equal to N into empirical formula. So here N is not 1, it is equal to 2. So we will write here 2 multiplied by BH3 and the answer is B2H6. So this is B2H6, that is the molecular formula of the compound. This we are to calculate. So I have dealt with 3 types of the numerical. In the first numerical, we calculated only empirical formula. In the second numerical, we calculated both empirical formula and the molecular formula, but their N, that is equal to 1. So empirical formula is same as that of the molecular formula. But in the third numerical, here N is not equal to 1, it is equal to 2. So from that, how we can calculate the molecular formula, that I have also told you. So I think the things, they are clear to all of you. You will practice on your own. As you know, practice makes a man perfect. I will come with another video of another concept of class 11th. Till then, thank you very much.